Hello everyone, it is good to see you here. I'm Derek, and today I will be going over how to display BIM data from models that we imported from the VFAT developed package or PiXYZ. First, I will be showing you how to make a user interface in Unity, and next, we will need to write some code to allow the data to be displayed on this panel on the right hand side. Without further ado, let's get started. Right, so in my last video, I showed you how to make an outline selection using the material that I find from the default VFAT viewer template in GitHub. And now we want to show the BIM data based on what we selected in the view. First, we need to build our user interface. It is basically a panel that has a scope view and allows you to add labels inside it. Let's go point the mouse cursor in the empty space under the hierarchy window and right click. Go to UI and Canvas. This will create a canvas game object for the user interface. Usually I will select the canvas object and go to the inspector, then select scale with screen size. Set the reference resolution as 1920 and 1080. Make sure to select match width or height and drag the slider to 0.5. This will make our user interface scale proportionally. And when we start building the interface, it is best to switch to 2D mode and move our scene view to oversee the whole thing, like this. Next, we will add an image game object to be our background of the panel. So right click on the canvas and select UI, then image. Now we need to make the panel always stay to the right hand side of the screen. And we also would like to make a panel taking up to only 30% of the width of the screen and up to 100% of the height of the screen. To do this, we will make the anchor to have the minimum values x as 0.7 and y as 0, maximum values x as 1 and y as 1. Then we will set the pivot as 1 on x and 0.5 on y. At last, we will make the left, top, right and bottom values at 0. Now we will have a panel that always sticks to the right hand side of the screen and takes the same amount of screen space no matter what size of screen we have. Now make the whole image a semi-transparent color so we can see through it. Next, we will create a scope view object. So we head over to the panel object and right click, select UI and scope view. And what we need is this scope view to be scaled based on the size of the panel background. So go to the scope view object and set the following values on the vec transform component. We will set the minimum anchors to 0.05 and 0.025, then 0.95 and 0.975, and set the all left, top, right, bottom values to 0. This means our scope view will always taking 90% of the width of the panel and having 5% of space on each side, and taking up to 95% of the height and have 2.5% of space on the top and the bottom. You can leave the image component on if you want to, but I will have mine turned off. Next, let's move on to the scope vec component. We will uncheck the horizontal checkbox as we don't need the scope horizontally, and we can select the visibility of the horizontal scope bar and set it to permanent. And while we're doing that, it is the best to select our scope bar horizontal game object and disable it, so it will never show in the view. Next, select our content game object and add the following components. So go to the Add Component button and add a vertical layout group and a content size filter components. The vertical layout groups will automatically lay out its child objects vertically, and we can set some parameters to adjust its spacing, etc. And content size filter will automatically resize its size based on what we set below. And in our case, we want to set the vertical fit as preferred size as we are laying out our data vertically. So under the content game object, we will start building our labels for showing the BIM data. We will make one template, and we use this template to count whichever number of data that highlighted object will have. We will make an image object and make it semi-transparent. We will add a layout element component and set the minimum height at 75. At last, we will add a horizontal layout group that can lay out our key label and value label. And we will set all the values into 1 and 5 in spacing. Also, we will check the control child size as true on both width and height. Now, select that object and create an image child object under it. And then make another label child object. We will make the image color as gray and select the label object and change the font to display all capital, size as 24, black in color, and set the alignment as middle. Also, we will like the label to expand, so we can press Shift and Alt on Windows or Option and Shift on Mac after clicking this icon, and select the bottom right one, and make all the top, left, right, and bottom value as 5. We will select the parents of the label, which in our case is the background object of the label, and duplicate it. We will name the label one as key and the other one as value. At last, we will disable the whole parents which contain the both key and value objects. Last but not least, we need to make sure we have an event system game object in the scene. Now we have our user interface ready. The next thing is to update the package that I prepared for you in the last video. I have made some adjustment. The major things that I made in the package is that I implemented the Unity event system into the highlight object selection script. What this means is that when we select an object, the script will fire up an event, and whichever script has subscribed to that event will get triggered. Also, I have changed the selection function to react to nothing when the mouse cursor is on top of any UI object. And now, we move on to make our new script to net our model BIM data to be displayed on the screen. Let's call it BIM data panel and open your script editor. First thing we need to do is to make sure our template game object is disabled, so it is not showing up as an extra entry. Let's call it PiXYZ, which is what Unity developers call it. Then we want to subscribe to that highlight event from the highlight object selection script. So on the top of the script, we want to make a reference to the highlight object selection script and the PiXYZ. Then we will create our awake and onDestroy functions, which will disable our PiXYZ, subscribe to that event, and unsubscribe it when it no longer needs it. Let's go over a bit more on the add listener and remove listener. In a nutshell, it basically says when our onHighlight event get fired, it will trigger a function call onObjectHighlight. And we want to make sure that we are passing the right parameter, and in our case, it's passing through a list of game object. It is time to implement our onObjectHighlight function. First, we will make sure we remove all the existing entries, and to make things easier, we create a reference that stores all the entries. So on top of the script, we create a reference called entries, and its type is a list of game object. And we will create a clean entries functions. First, we start by checking if there are any entries. If no entries are fine, we will return and make no further processing. If there is, we will destroy all of them. At last, we will clear the list. Going back to our onObjectHighlight function, we will run the clean entries to clean up all our panel, and we will check if there's any objects get highlighted. If there's no object get highlighted, we will make no further processing, which we will put return if it's equal to null. This means empty. Next, we will go through the list of highlighted objects and we check each of them has a meta component by using try_get_component. So if you are using PiXYZ to bring the model in, we will use the PiXYZ library, and if you have a model using VFlat develop, we will use the VFlat library instead. Then we will go through all the properties of the components, and we will use instantiate to make copy of the PiXYZ. But before we do that, we need to make a reference of our scope view, so we can directly instantiate the PiXYZ to be a child of the scope view content object, like this. We can turn the new entries on as the PiXYZ disabled when we instantiate it at the first place. Now, this is the important bit. Remember, we previously named our object as key and value. We will need to match that in this section because we are going to get the objects by using transform.find, the object name. and the object name is case sensitive, so we need to make sure they are matched exactly the same, and we can get the text component out of it by using getComponentInChildren and set the text like this. We will also need to do this for the value. At last, we will add the new entry to the list, and we will test it now to see if this works. Here we have a model imported using PiXYZ, and we make sure we have a collider to be able to be selected. And let's run the scene. It is now highlighted and showing the BIM data on the side, which is good. Now, let's go back to the script and let's make it working for the VFAT developed package too. We can copy most of the stuff here and paste it at the bottom. We just need to change a few things. First, change from using PiXYZ library to using VFAT library. And instead of going through get properties, and we will go through each entries of its parameters, and we will change those to parameters, and the value one we put parameters.value.value. There are two values there. So let's hit save and test it with a model that is imported by VFAT develop, making sure we have a collider inside the model and run the scene. And there we have it, a panel that shows all the BIM data from the model. This is what I have got for you today. I hope you enjoy it. Thanks for watching.